In this session, we'll look at Friedel acylation of benzene. So understand the Friedel acylation mechanism, and also learn the reagents and the catalysts, reaction conditions, and also how to find the product using the reaction mechanism. So let's get started. So let's say we have a benzene ring like that. So this benzene ring we have is undergoing what is known as Friedel acylation. Then these are the reagents we have. So CH3, CH2, CH2, COCl. Then with below here we have aluminium chloride like that. So the first thing we must do here is we react these reagents. So we have 1, 2, 3, 4. We have 4 carbons. So the first thing, reaction of reagents. So reaction of reagents. So what we are going to have is this. So we have that bonded to a chlorine. So this is the structure we have there. Then it is reacting with, we react it with aluminium chloride first. So we know that this chlorine has lone pairs of electrons, so it will be able to attack the aluminium there. Then we are simply going to form this structure. So we are going to form a structure like that. Then this is bonded to the chlorine. So in this case, because this chlorine is the one which is grabbing the aluminium, so this one will have a positive charge. Then we'll have the aluminium chloride like that. Then this aluminium will have a negative charge. So this is what happens. Then the next thing, we can get that structure there, which is like that. Okay. So we have that structure. Then it has a positive charge there, bonded to aluminium chloride, which has a negative charge like that. So this now will leave. This has been made a good leaving group, and it will be the one which is going to leave. Then once it leaves, this group, once it leaves, it is going to form this structure like that. So I have our oxygen, of course, with lone pairs like that. Then it will have a positive charge because this group has left, so it will remain with a positive charge like that. Okay. Then once we have formed this, our electrophile, this is our electrophile. We can now react it with benzene. So let me erase this. Okay, I should leave the benzene which is there on top. Alright, so now this benzene will now react with the electrophile which we have formed, like that. It's a positive charge, like that. Okay, so what we are going to do here is that the double bond there will attack this electrophile, and what is going to be formed will be this structure. The double bond there has attacked the electrophile, then this structure will be attached like that. Okay, I think I need to erase one side. Okay, so it should be like that. Then here we'll have a carbocation since the double bond was broken. So we're going to get that structure now. We get that structure like that with a carbocation. So it has a carbocation there. One thing we're going to do here is that since we have a carbocation here and we have a hydrogen here, we can use a base. We're going to use the same base which we formed, which is the same base which left actually, which is aluminium now tetrachloride. Okay, remember it's left with a negative charge, so it will come and grab this hydrogen, then the bond will be broken, then this bond will form the double bond in this ring. So we're going to have now this structure. So once the hydrogen has been deprotonated, then we'll have a structure like that. Okay, so this is now our product after we do Friedel acylation of benzene. Of course, we're going to form, even this will be part of the product once it reacts with the aluminium tetrachloride. So other products will be plus the aluminium chloride from this, then plus of course the HCl, the hydrochloric acid. So these are the products we are going to form. So we are simply going to have these products, which are these products and these byproducts. Thank you for watching.